So what do we know? Where do we go from here? I know I'm going straight for the bar from here after the conference. I'd like to start with Paul Anderson's introduction, and he talked about National Parks Central Alaska leading your mind, your skills, ideas, and dedication, and they need your hearts. And I don't know about you, but that's one thing I certainly got out of the talks was the hearts that have gone into a lot of the work here. You can just detect the kind of passion and the emotion in some of the studies. And hopefully you guys would agree with me that that is one thing that comes forward. And I think that really takes research in these areas to a different level. If you've got that affiliation, that attraction, it really pushes you forward rather than, say, you're working on a river in the middle of Pittsburgh or something like that. So that's really the first point that I really want to make that came through to me in terms of these talks. But I thought a lighter moment, there's some interesting words that I've learned this week about side slip and strike slip. Sound a bit like kind of baseball terms. The geologists get it all. Rock jog, I thought that was a great term. Terricolis, plutons, I didn't know what a pluton was. I hope that's not going to be downgraded like they've done with the planet Pluto, but hopefully that won't be the case. And I never thought Caribou Down could be so interesting. So I have a new kind of affiliation to that. It's a bit contrite quoting Confucius, but he did say that study the past if you would define the future. And it's funny, I think as Americans, we tend to feel that we have no history. I'm originally from Europe, but no, I can say that. So hung up about not having the history, but that William of Orange stuff and the Roundheads, it's all so boring. To me, this kind of more contemporary history is far more exciting than 20th century kind of stuff. And I really think that gives a context for the work. It kind of gives you a kind of feeling of tranquility, knowing there's some kind of history behind the areas that you're working with. Hopefully you will agree with me. And and it also provides, as we heard, some of the kind of long-term records. Pam talked about these snow records dating back 80 years. Carol was talking about the birds and the different records that were available from people like Sheldon and, remind me, Carol? Dixon, that was the one, Dixon I was trying to remember. And these are very important records to put things into context in today. And then we have other kind of techniques as far as the Iceberg Lake study that Mike Lasso talked about. And this late 20th century that he was able to get had warmed more quickly than any other period, including the medieval war period. So I think this kind of ability to stretch back into the past is absolutely fascinating and gives us this kind of perspective. And I think it's clear that the value of long-term data sets. It's very clear that we learn so much from long-term data sets, and that without that we can miss some of these kind of trends, particularly in this kind of changing environment. And I should also point out that I can't cover every study that's been talked about in this meeting. And so don't get upset if I don't include your study. You can leave me in the groin outside afterwards, but if it's not included, don't please be upset. I just had to pick some threads to kind of go through. I don't know if you guys know this book, the Arctic Climate Impact Assessment book. It's just been published. Great value. You never get a better value of a book on the market. 1,200 pages almost for $195. Work that out per page compared to most textbooks. And I just reviewed this book, and all the people associated with this book, this is an incredible book. Some of the chapters are written in such amazing depth, and you're really satisfied after you read a chapter. But a lot of the chapters really focus on the use of traditional knowledge. That really comes through about how valuable that is. And when you read any chapters in this book, that is a main kind of element of it. And I think we had these studies that comes through, that just mentioned some of here, the beluga whales, Yakutat Bay, the native elders regarding the interior Alaska lakes that were drying. One we heard this afternoon on the Upper Tanana subsistence fisheries, the Chisna caribou herd, and the Yukon ice patch. So all of these had elements of this traditional knowledge, and I think that is something that is really valuable, that really came through, and something we, in the future, we have to make sure those connections are made. Now I want to talk about major drivers in this changing environment, and we can't get away from the hard rock geology and talks of the plate tectonics, like Phil and the faulting. I mean, these are changing the landscape, and so they are very important drivers. Other major drivers in this changing environment, clearly we heard a lot about climate from Pam's talk, snow cover, and in relation to hydrology, glacial accumulation and ablation, and permafrost dynamics. And clearly permafrost, particularly in the two interior parks, is going to be a major driver of the landscape in the future. And this really came home in Tor Gordonson's talk, and the fact that approximately 7% of the boreal landscape was recently degraded, and 50 to 70% is likely to degrade in the future. So this is going to be a major driver of the landscapes and the processes on it. As ecologists, we often talk about disturbance, and disturbance is again a major driver. And disturbance will clearly, these disturbance regimes will be playing a major role in this changing environment. This came through in quite a few talks. And Terry pointed out that disturbance has a key role in structuring landscapes and determining the patterns of distribution and abundance of organisms. And some of the ones that we heard about were different kind of flood events. We heard about increasing seismicity along the Denali Fault, and even things like military aircraft and the effect on Dall sheep. So there's a whole range of kind of disturbance regimes as a major driver. But clearly here, particularly in interior Alaska, we heard about fire. And again, this is another disturbance regime. We heard from Scott Roop that doubling of the total area burned in the last 50 years. And the models indicate increased burning in the next 100 years. So this is going to be a major kind of driver. We'll come back to that in a little bit more detail. Bruce Molnier gave us this list here of potential drivers as far as disturbance events along the coastline of Wrangell and Elias. And you can see some of the things like coastal erosion, storm surges, mass wasting, and sedimentation, as just to name a few. Another major driver we heard about was Pacific Decadal Oscillation as a major player. We heard about its relationship to air temperature, not to snow cover directly, but Pam pointed out the relationship to air temperature. Eric Redstad, all the way from Scotland, told us about its effect on small mammal populations. It was a major driver of that. Eric Redstad's abstract mentioned that the mean biomass of voles was greater than in Denali than the biomass of bears. I thought it was very interesting. And I would like to say to Leon Adams, put that in your pipe and smoke it. And we also heard that the PDO drove stream macroinvertebrate communities in unstable channels. I also want to point out I had an idea as well through the talks, and I want to point out that I'm not going to mention the word charismatic because I can't get it out, so that's not going to come into the talk. But I've decided that the class next year will be called Braids, Bugs and Bears. Braided Rivers, Bugs and Bears. And hopefully there'll be a sign-up sheet as you're going out the door to make sure we get the 12 people. I also wanted to point out, when I was talking about stream macroinvertebrates, I know some people didn't believe me, but if you look at Lucy Terrell, please, Lucy, stand up. She is actually wearing caddisfly earrings. And Apparently somebody gave it her as a present. You didn't believe it that caddisflies make these earrings, did you? Somebody gave that to her as a present, apparently, and this is the first time she's worn them. I think this is a very important point that came through in the conference, was the fact in this changing environment that not only will some of these drivers change, but some of the timing of events will change. So that events will not occur at the same time as they might have historically done. And that can potentially have some major influences. And it was opposed by Tim Brabitz, who was talking about earlier Yukon River flows. Icing. I always just think of ice as your unwelcome house guest. The kind of person that comes early, drinks all the beer, and stays right to the end before they leave. But icing is changing. Icing is not such an unwelcome house guest anymore. It's arriving later, it leaves early, before midnight, doesn't drink all your beer, and it's ameliorating, and so we're getting a changing environment. We heard from Brad Griffiths about the earlier greening of vegetation. And we also heard about the duration of the winter snowpack, which has potential knock-on effects. And just briefly I want to talk a little bit about indicators of a changing environment. I mean, what indicators have come out as we've gone through this, listening to the talks, that we are living in a changing environment. One clearly is this idea of more heterogeneous vegetation post-fire, and the opportunity potentially of increased moose browse availability. I mean, patch dynamics is a big thing. Heterogeneity, and disturbance creates patch dynamics. That's what the main driver is. And maybe with more disturbance, we'll have more heterogeneity in the habitat, which is not necessarily a bad thing. We heard about the expansion of the forest into the alpine, and evidence for that, reducing lichen abundance, which potentially has knock-on effects, of course, for caribou. But Carol told us about changes, indicators of songbirds, the orange-crowned warbler increasing, and the whimbrel kind of disappearing from this historical database. We know about glaciers and lakes, and Keith talked us through that glaciers are typically thinning, but not all of them. As Bruce was pointing out, some tidal water glaciers are actually advancing in some areas, like the Hubbard Glacier. Amazing sedimentation rates that Bruce talked about for the Hubbard Glacier. But I thought this was a great slide from Keith Eckelmeyer, this idea of how much these glaciers are actually contributing to sea level rise and melt in Alaska. And very high there, and apart from that 2005 data from Greenland, was the highest contribution to sea level rise. And we heard from Amy Larson about the loss of lakes on the landscape and the potential effects for that. Hopefully less mosquitoes, but I guess that is not necessarily the case, because they might be getting shallower, and mosquitoes like shallower lakes. But the evidence is before us, these indicators. And this is Carl's stuff as far as the vegetation on the gravel bars. We're seeing this, and the fact that this landslide, fault activity that we're seeing on the ground. These indicators are right there, and also indicators of. We heard this morning about recreational visitor experience in Denali. These are all part of the indicators that we're seeing. Patricia's talk, and this is really getting into this idea of crossing boundaries in a changing environment, about these invasive species, Melaleucus alba. And as she pointed out, there are many other species that become invasive, and possibly some of this is due to this changing environment and climate change. And we need to understand these routes to cross these boundaries and what effects these will have. All right, this wasn't necessarily, this was up in the NOAATAC, and wasn't the Central Alaska Parks, but I thought this was fascinating, this transboundary and these pollutants that Landers is working on, and Bud and Andrea. And this is classic tragedy of the commons, and the fact that these pristine environments that we assume are pristine are being hit from contaminants generated from far distances in Europe, in Asia, and in Russia. and the fact that Barrier Lake had this mercury that actually exceeded the EPA criteria for human consumption. I presume there's no subsistence fishery on these kind of labels. So where do we go from here apart from going straight to the bar? Well, here's the challenges I think for the future, and some of them relate around human population. And Terry talked about this in the essence of increase in visitation use. As human population increases, more possible visitation, and this has to be kind of acted on. But Landis made a point about Asia's population potentially increasing from 1 billion to 3 billion, and what would be the effect of that? And it links back to possible more kind of pollutants kind of crossing these kind of boundaries. And I took this from Andrea's poster about what role can the NPS play in mitigating these threats that are beyond their boundaries. And she had that they must inspire people to be concerned about issues beyond their own backyard. So hopefully people come to these areas, are so fascinated to hear about these issues, and then will be willing to do something that's beyond their backyards. And develop these education programs to help people better understand the threats. And we heard that this morning. I thought there were some great talks about these educational programs, like interpreting global climate change. And we talked about the things with the native communities as far as building on their knowledge, but it shouldn't be just a one-way aspect. I mean, I think we need to feed back to them and answer some of those questions Isaac talked about. Well, we don't know why these things are happening, but we think that we have a role to play to feed back to these communities about what some of our findings are. I thought this talk from Martin Jeffries this morning was great about the use of K-12 students in collecting data, and this kind of aspect of utilizing this resource and getting them interested at a young age. I mean, everything depends upon getting kids at a young age, interested, and then, some of the things we're talking about as they carry on later on, they can help with some of these environmental problems. So I thought this was a great network, and should really be applauded, his efforts that he's done on that. Now, as research scientists, we often thought to live in these ivory towers, that I'm thinking more as university scientists here. But this is changing. In the essence of now, when you write an NSF grant or any kind of grant like that, you have to have some kind of a component in there where you are going to be able to disperse your information to the general public. You will not get grants to do that. And I think this is good, that this is a challenge that we have to face as research scientists, that we can't just live and just publish our papers. I mean, I don't know about you, but as a research scientist in a university, there's such, the publish and perish idea. And then, the citation indexes. And you look at your publications, and you can see how many times a person has read or cited your paper. And I tell you, it's so depressing. I mean, you've written this thing taking you years, and look at it, and it's only been cited 7 or 8 times. It's like, well, shall I just do the honourable thing and, jump off the highest building? But it just tells you that we're just talking to a small group of people, really. In my own field, any paper that gets 50 or 60 citations is doing really well. So we have to get this role of getting our information out to more of the general public, particularly to resource managers, and as we heard this morning, to interpreters. And I think that is a very, very important role that we have to go for, as far as going from here, that we have to do more of. Now, there is a quite illustrious scientist in this room, well-known research scientist, trying to disperse this information. We've got a little clip here for you. It's Friday afternoon, Thursday afternoon's light. Trying to explain to his 3-year-old son how the dinosaurs went extinct. And then his 3-year-old son then tries to give him the explanation back if he's understood this version of information. So to see how this illustrious scientist, how well he did with trying to explain to his 3-year-old son about the extinction of the dinosaurs.
Yes, guys. These are where the dinosaurs came from, right?
Yeah.
Yeah. And now there's no more dinosaurs there. They died in a volcano.
In a what?
All the dinosaurs, in here, all the dinosaurs just died in a volcano.
In a potato?
No, in a volcano.
In a volcano?
Yeah.
Oh.
Yeah, because the volcano exploded away.
Oh, it exploded?
Yeah.
So how did the dinosaurs die then?
The volcano, this got a lot of steam out, and then all the dinosaurs just died.
Oh, yeah.
Yeah, that's how the dinosaurs died.
Oh.
Okay. We talked about the value of long-term monitoring, and I think, as mentioned here, the I&M program has an incredibly important role to play in this. I mean, there's a block of money that's going to be allow some long-term studies to go ahead, and this will help our understanding of the consequences of this changing environment. Just one point, though, and I wanted to mention, and this seems probably the main players aren't here, but while I think it's important that the networks within Alaska focus on the issues that are important in the region, I think this is such a unique opportunity to be able to cross boundaries, across these networks, and measure some key variables that will give us something for Alaska. This could be done fairly kind of cheaply. And I would just make a point that maybe there should be some cross-boundary going on here in this program. And some of these measurements I'm thinking of would be fairly simple to do, and will give us something that we don't really have for Alaska, and that's right across the whole state. So it's just a plea that there is some cross-boundary thing doing to look at some potential variables that could be measured that across the whole state. Some of the things that, as far as where do we go from here, I think we have to try and, this came a bit from going, how about understand predator-prey relationships and how they will alter with a changing environment. How will food webs change? I mean, this is very important. I mean, it's clear that some of the players in these food webs are going to change. But does the function of the food web on that landscape change? I think we have to really understand that. And if functionality doesn't change, then does it really matter that the players are changing? Hotspots. That's not a wireless hotspot. What I'm talking about is hotspots of productivity on these kind of landscapes. And I think it's very important that we identify those and to ensure that they still continue as hotspots. And we heard from Scott, it's mulets, when there might be hotspots, these high patches for caribou that we heard about this morning. I hope you should be really impressed on this. I mean, this talk was only given 15 minutes ago, and I've already got it incorporated into my talk. And I think it's a very important subject. I'm not quite so sure I like the term healthy tension. I think of it as my teenage son asking to take the car out, and I'm saying, "You'll be back at 11 o'clock, please." And he's 6'4". And he says, "No, I'm coming back at 1 o'clock in the morning." "No, please go back at 11. It might be a healthy tension for him, but it's not a healthy tension for me. So, interesting term. But I think there's this was a very important talk, because I think it's clear that as we go forward to try and answer some of these questions that we're talking about, then there's going to be these potential impacts on the kind of these wilderness and what will be allowed and what won't be allowed, to do that. Because once you put a climate station in, it takes a certain amount of impact to go and service that climate station. And particularly in the terms of long-term monitoring, if you start a long-term monitoring program, you have to be sure that you can continue doing that. You don't want to invest all that time and get so far along and then find that the playing fields or the goalposts have shifted. And I think this is very important, and I was pleased to see that there was this potential for negotiation. And whether there should be some ability of grandfather rights once you start off something, that you can keep doing it, you know. But it's important, if you invest a lot of time into a program, and you want to keep it going, that can be possible. Another thing that should be mentioned in this context to other issues is the essence of, if you apply as an independent scientist to National Science Foundation funding or whatever, you can't do it for monitoring. They will not give you money just to go out and measure the number of insects in a particular thing. You have to do some kind of manipulation or experimental manipulations. And without it, you won't get any money. And that, again, in the context of, you know, what can be allowed and what can't be allowed. And one final point on this, you know, as far as what might have no benefits, you know, it's hard to say. Something might appear to have absolutely no benefit now. Some variable you might think about, but why measure it? But 20 years from now, it could be really important in this context of a changing environment. And that's been shown, you know, where they thought, well, why did people start measuring that? And then suddenly it comes into an important point. So I think that's another issue that has to be considered kind of in this matrix. And talking about matrix, Terry pointed out about the importance of thinking outside the box. And this idea that, you know, we have these parks, but they're not in isolation. You know, and we have to think what's happening around those parks and manage those matrix around the parks. It's very, very important. Just a few other things to... another challenge, I think, is identifying feedbacks in this changing environment, both positive and negative. And this is really important. Things like snow and albedo effects, we heard something about that already. This forest expansion, this will enhance local climate warming. We heard from Brian Griffiths about, you know, this early greening, so the caribou do better as far as the lactating females, but then food goes quicker. And then there's thinner ice, so you got initial positive action, but then you got two negative actions, so the net result is a negative effect on caribou. We have to understand these complex interactions in this changing environment. And what are these changing windows that we've already talked about, these shifts of windows, you know, what are the ecosystem effects? I thought this was one of the most amazing things at the actual symposium was this quilt. And I think that people involved in this deserve a special congratulations for spending so much time. They particularly like the silty rivers. They got that exactly right. No bugs living in it or whatever. The reason I want to mention this is this shows some interactions, some knitting together of different kind of ecosystems and the players on those ecosystems. And I just want to point out, after this Glacier Bay Science Symposium, some of us got together, and this is a changing environment, and we'd all worked together for 20 or 30 years in Glacier Bay, but we'd never talked to each other. And one of the players in this room, Lewis Sean, was involved in this, Terry Chapin, Chris Fasty. And we'd all understood our own ecosystems. And suddenly we thought, well, how do they interact together? And we spent quite a lot of time doing this, and we came up with these, how are these interactions between the lake environment, the terrestrial, the stream, the marine environment, and how those changed over time. And I think it's very important that now, and a challenge to you as scientists, to start talking to each other and building these links, because no ecosystem operates in isolation. And if we're having this changing environment, we have to understand these linkages, or we'll not really understand what's doing. And the thought of me sitting down with Lane Adams and trying to create a linkage doesn't really appeal, but we're willing to do it, you know, to ensure that this connectivity is done between scientists. And we saw a little bit about this from Landers' talk, that they already started thinking about these kind of linkages. I think modelling is an incredible tool and a very important tool for predicting some of these future changes. And we already saw Scott talk a little about models for fire, small mammals, the carrying capacity of vehicles on a Denali road, and although one exactly models the soil cover maps that Mark talked about, and the prediction for fire-prone areas and such things. But other things, Terry suggested explore new models for living with change, and maybe these patch dynamics under different disturbance regimes. In the bar, I will give you a quote about modelling, which I can't really give to this meeting. It's probably got a bit of a, this is a family group meeting, but there was actually a quote in the Journal of Soil Science about the value of modelling. So ask me about that later, and I'll tell you what was written in that journal about how valuable modelling is. This was Igloo Creek, the first dinosaur footprint in Denali in the late Cretaceous. And I'll leave you with, what will be the footprint on the landscape of Central Alaska Parks 100 years from now? What will be the human footprint? What will be the footprint of the different fauna and flora? And I think this is be a fascinating challenge for all of us to try and develop this, to see what will happen in the future. And I think this symposium has helped as far as starting us on that road. So thank you very much.